Discuss case number 3 in partial fraction, which is denominator containing quadratic functions. So let's see how we are going to solve quadratic functions which will affect the partial fraction. So let's not waste time talking too much. We'll dive directly into an example. Let's take this example. So x squared plus 1 times x plus 1. So this we will write it as x squared plus 1. It's like the same, we just split the factors, plus x plus 1. So x squared plus 1, like I told you earlier, here you see this x squared plus 1. I always told you before, we have to, on the numerator we have to write a degree which is less than the degree in denominator. So in this case it would be x to the power 1. So we write it as ax plus b, and here we write it as c. This is the usual case. So now afterwards it's going to be simple solving this. It's like the old problems. We write ax plus b times x plus 1, taking x squared plus 1 as the common denominator. So we have x squared plus 1, which is equal to x. Now it's simple. Now we're going to solve this by putting x equals minus 1. So when you put x equals minus 1, what do you get? You get x times c times x squared plus 1, and then when you put minus 1, you get c times 1 squared plus 1, and which will leave c equals as minus half. And then when you put the next, you put x equals 0. When you put x equals 0, what do you get? You get x equals b plus c and minus half. So you get b equals half. So we have found c and b. Only thing left to find is a. Now to find a, you put x equals 1. You get 1 equals 2a plus 2b plus 2c, and you substitute the values that you found before. You will have a as half. Now that you have found all the variables, all you have to do is substitute x over x squared plus 1, x plus 1 equals x plus 1 x squared plus 1. Here you take the half to the bottom, and minus 1 over 2x plus 1. So this will be the final answer of that problem. Let's see another problem which is a little bit different from this. So it's going to be 1 minus x over x plus x squared plus x cubed. Now isn't this interesting? So now what do? You take the x in the denominator common. So we will have x squared plus x plus 1. So this you write it as a over x plus bx plus c over x squared plus x plus 1. Now you take the common denominator as x times x squared plus x plus 1. So now you will be left with a times x squared plus 1 plus x times bx plus c. Now the solving part is pretty much easy. All what you do now put x equals 0, you get a as 1. And then now you equate coefficients. You equate x squared coefficients. So when you equate x squared coefficients, on the left hand side it's 0, have ax squared plus bx squared on the right hand side. But we already know a as 1. So which will leave b equals minus 1. And then you put x equals 1. And then you put x equals 1, which is 1 minus 1 equals 3a plus b plus c, which would leave c equals minus 2. So now we have found everything that we need. We have found a, b, and c. Now all we have to do is substitute the partial fractions. X plus 1, which would leave us the final answer as 1 over x minus x plus 2 over x squared plus x plus 1. This will be the final answer. Okay, that's enough for it. That's enough for case 3. So basically what you have to remember in this is, when you have a quadratic function, you always write it as ax plus b if the power is 2. In case if the power is 3, you write it as ax squared plus bx plus c. Generally, people or the examiners only question which the power is squared, so you don't have to worry about what will happen when the power is 3. So yeah, that's it, guys.
Thank you guys for watching the video, and if you guys like the content that I'm doing, don't forget to subscribe and give it a thumbs up, and also you can follow me on the Instagram Maths4Me.